In this video, we'll be talking about the two important trigonometric limits. Now, they're all the basic appropriate limits. For instance, the limit as x approaches 0 of sine of x. You can plug 0 into x for the limit as x approaches 0 of sine of x, giving you the sine of 0. The sine of 0 is nothing more than 0. So that is not a special trigonometric limit, it's simply the substitution method of evaluating a limit. What we're talking about is a limit that looks like it shouldn't actually exist. For instance, the limit as x approaches 0 of sine of x over x. Now, if you were to look at this particular limit right here and attempt to plug in 0, you would once again get 0 over 0. But this is not allowed to end up with. So what are we going to have to do? Well, keep in mind that none of the analytical methods that we've used in the past actually work to evaluate this limit. What we're going to have to do is return to the good old-fashioned way of either looking at the graph, and the graph of this doesn't actually look all that difficult, but the more appropriate way to look at this would be to use the numerical table. So in that case, you're going to plug in values getting it close as possible to 0. You're going to want to do this from both the negative side and the positive side. So start, say, at positive 1 and then go to 0.5 and then 0.1 and then 0.01 and then 0.001. You'll do this from the negative side, starting at negative 1, going to negative 0.5, then negative 0.01, then negative 0.001. And you'll notice that when you're done using the table, this limit is actually equal to 1. So that is your first special trigonometric limit rule, is that the limit as x goes to 0 of sine of x over x equals to 1. Your second special limit rule is as x goes to 0 of 1 minus the cosine of x over x. This value actually ends up being equal to 0. So again, you'll notice here that if I plug in 0 for this limit, I get 0 over 0. And we called that in a previous video an indeterminate form. It means that we can't determine exactly what that value is going to be without more work. In this case, we use a table of values to identify that the limit as x goes to 0 of sine of x over x is 1. Now if I plug in 0 to this limit, you'll notice again I get 1 minus cosine of 0. Cosine of 0 is 1, so I get 1 minus 1, which is 0, divided by 0. And you're thinking, well, I get 0 over 0. Shouldn't that be 1 like this one back here because I had 0 over 0 for this one? And the answer is no. This is an indeterminate form. This gives me a value that doesn't make mathematical sense. Keep in mind that 0 is not being actually divided by 0. It's something approaching 0 divided by something approaching 0. The pace at which they approach 0 will actually determine what the value ends up being. So the argument for this one right here is that this top value is actually approaching 0 faster than this value is. It's approaching it so fast in case of the situation that this top stuff overrides the concept that this eventually goes to 0. So it's 0 over something very, 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 very small. It eventually will approach 0, but this one approaches 0 so fast that we end up with 0. Whereas in this case, the sine of x and x approach 0 at the exact same rate. And them approaching 0 at the exact same rate provides us with something very small divided by something very small but equivalent. Something very small but equivalent. And therefore, eventually, we're going to get to something so small that it's nearly close to 0, divided by something so small that it's nearly close to 0, but those two numbers are the same, that we approach 1. So those are your two special trigonometric limits. What we're going to look at next is an actual example, the first example being the limit as x approaches 0 of sine of 3x over x. Now, before we actually delve deep into this example, make note that this rule right here only works when it's the sine of blank divided by blank. And I'm saying it that way because it must be the sine of something over something. And those somethings must be the same. So the fact that this 3x is here is great, but the fact that there's no 3x here is a problem. The x is good, there needs to be a 3. Well, from our limit laws, remember that I can take a 3 over 3, and I'm going to multiply this limit by 3 over 3. When I do this, am I changing the value of this limit? And the answer would be no, because I'm multiplying by 1. Now, because this is a multiplicative constant, I can take this 3 and pull it into the limit without any ramifications, giving me 3 sitting on the outside times the limit as x approaches 0 of the sine of 3x over 3x. And the idea is that as x approaches 0, the sine of something divided by something will go to 1. So this limit is then going to be equal to 3 times 1. And again, the only reason why we're allowed to pull this constant into the limit is because when we do so, this limit now exists, and I can evaluate it. And again, just because the 3x is different than the x up here doesn't change the rule that if I have the sine of something divided by something, as x goes to 0, that overall limit is 1. So this provides me with a value of 3 for the limit of sine of 3x divided by x.